Hello viewers, welcome to my channel. I'm Hasham Ali Khan. So far 6 problems I have completed on simplex method. First 3 problems on maximization type. Second 3 problems on minimization. Now 7th problem is on mixed constraints. Some inequalities are less than equal to type and some inequalities are greater than equal to type. So if you remember, in maximization type of problems, we have seen all the inequalities are less than equal to type. Whereas in minimization type problems, all the inequalities are greater than equal to type. But here we have mixed. So whenever we have less than equal to type, we have added the slack variable. When the inequalities are greater than equal to, we have subtracted the surplus variable and added artificial variable. These are the things already we have done in the previous problems. So first of all, it needs a lot of practice. These problems, simplex method, you cannot be able to understand by just having one glance. You need practice. So if you have not watched the earlier videos, I suggest you go to the playlist of my channel. Select the subject operations research. Select the videos of linear programming simplex method. Be perfect about the procedure, have good practice, then definitely you can be able to solve the problem of simplex. Now, before starting the 7th problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Take the screenshot of the points, then I'll explain. See the 7th problem, mixed constants. Solve by simplex, minimize z is equal to 30x1 plus 30x2 plus 10x3. Subject to constraints 2x1 plus x2 plus x3 greater than equal to 6 and x1 plus x2 plus 2x3 less than equal to 8. The problem is of minimization type, but one inequality is greater than and the other inequality is less than, and x1, x2, x3 are greater than equal to 0. This is the non-negativity restriction. So here the problem is like this: 30x1 plus 30x2 plus 10x3. So coefficient of x1 30, x2 30, x3 10, and 2x1 plus x2 plus x3 greater than equal to 6 and x1 plus x2 plus 2x3 less than equal to 8. Now we have to introduce all slack variable, surplus variable and artificial variable. First inequality is greater than equal to type. So we have to deduct the surplus variable and add the artificial variable. Second constraint is less than equal to type. Here we have to add the slack variable, right? So introducing the slack, surplus and artificial variable, the standard form of LPP will be as follows. Now see carefully. The original objective function 30x1 plus 30x2 plus 10x3. We are adding one slack variable and deducting surplus variable. So S1 and S2. So we require plus 0 into S1 plus 0 into S2. And one artificial variable also we have to add because the inequality is greater than equal to type. So plus MA1. The minimization type problem we have to plus MA1. Now subject to constraints 2x1 plus x2 plus x3 minus s1 plus a1 because the inequality is greater than. When the inequality is greater than, minus surplus and add artificial is equal to 6. Second constraint x1 plus x2 plus 2x3. Now here it is less than equal to type. So we have to add the slack variable plus s2 because s1 already we have subtracted here. Now we give the name s2 is equal to 8. So this slack variable, surplus variable, artificial variable, we need to convert the inequalities into equations, right? And all the variables x1, x2, x3, s1, s2, a1 all are greater than equal to 0. Now an initial solution will be obtained by taking x1 is equal to 0, x2 is equal to 0, x3 is equal to 0 and s1 is equal to 0. Because finally we need a1 is equal to 6, s2 is equal to 8. Don't take s2 is equal to 0. If we take S2 is equal to 0, all will become 0. 0 is equal to 8. It is irrelevant. So don't take S2 is equal to 0. Keep S2 as it is. So take x1 0, x2 0, x3 0 and S1 is equal to 0 such that A1 is equal to 6, S2 is equal to 8. Now first simplex table. As usual, Cj, the coefficient of objective function in the row as well as column. So basic variable solution value x1, x2, x3, s1, s2 and a1. These are the values. Now first simplex table, it's very easy to make because we don't require any formula, no calculation, simply we take the coefficients. So a1 is equal to 6 and a2 is equal to 8. The coefficient of a1 is m. So I have taken m. The coefficient of s2 is 0. Right? Now we take the coefficient of constraints. The first constraint is 2x1. So 2 here. 1x2. So here 1x2. 1x3. 1x3. And then s1 is minus 1. S1 is minus 1. And a1 is plus 1. That's all. Here 0. Right? Now second, 1x1 and 1x2, 2x3, then s2 plus 1, then 0, 0. That's all. First, we have completed first simplex table. Now we need zj value. Multiply the cj value with the variable. M into 6 is 6m. 0 into 8 is 0. So here I will write down 6m. Here m into 2 is 2m. 0 into 1 is 0. M into 1 is m. Because 0 into 1 is 0. M into 1 is m. 0 into 2 is 0. M into minus 1 is minus m. 0 into 0 is 0. M into 0 is 0. 0 into 1 is 0. Here m into 1 is m. And 0 into 0 is 0. So we got all the values of zj. Now we need cj minus zj. Cj is on the top. 30 minus 2m. 30 minus 2m. Here 30 minus m. Here 10 minus m. Here 0 minus minus m will become plus m. 0 minus 0, 0. M minus m is 0. That's all. Now remember the optimality test. For optimality test, that is minimization. If the problem is minimization, the optimality test says all the index row elements, this is the index row, all the index row elements should be zeros and positives. No element should be negative. If there is negative element, this is not the optimum solution. We have to make another table. So the most negative should be selected. But how to identify which one is negative? Because m is there. So we have to suppose. Let m is equal to. M means the highest cost. The biggest cost than the actual cost. The actual cost is 30, 30, 10. In the previous problems, I have taken m is equal to 10. But here I can't take m is equal to 10. M should be more than 30. So we can take 31, 32, 33, any value which should be greater than 30. No, so for easy calculations, I will take let m is equal to 50. Because easily we can calculate. 50 is greater than actual cost. So first here 30 minus 2m. So 30 minus 2 into 50. 30 minus 50 into 200. So 30 minus 100 is minus 70. This is the first value. Second value, 30 minus m. 30 minus m. 30 minus 50. That is equal to minus 20. And 10 minus m. 10 minus m. 10 minus 50 is equal to minus 40. Right? These are the negative values. Optimality test says all should be positive. But we don't have positive. This is not the optimum. Now select the most negative. Out of these three, which is the most negative? Minus 70 is the most negative. For which variable? 30 minus 2m. So 30 minus 2m, this is the entering variable for the next iteration. This x1 will enter. In the next table, x1 will enter. Now which will depart? It depends on minimum ratio. I forgot to draw the column for minimum ratio here. So here we calculate minimum ratio. Minimum ratio. Minimum ratio is equal to solution value divided by intersectional element. Solution value is 6. 6 divided by 2, 3. Here 8 divided by 1 is 8. The whichever is minimum. 3 is minimum. So 3 means which variable we have here? A1. So A1 will depart. A1 will depart. In the next iteration, x1 will enter and a1 will depart. So here I am writing simplex table 2. x1 enters and a1 departs. When a1 is departing, there is no need to open the column of a1. A1 column we don't require. It is departed. Right? Now, first we need to calculate the values of the entering variable. Which is the entering variable here? The entering variable is x1. The entering variable is x1. See. So in place of a1, I am writing x1 and second s2 same as it is. So x1, the coefficient is 30 and here s2 coefficient is 0. That's all. Now we have to find out the values of the entering variable. Entering variable is x1 is equal to values of departing variable a1. A1 values are 6, 2, 1, 1, minus 1 and 0. Remember, I am not taking a1 because a1 is departed. Divided by intersectional element. What is the intersectional element here? 2. Divided by 2. So 2 3s are 6. 2 divided by 2, 1. 1 divided by 2, 1 by 2. Here also 1 by 2. Here minus 1 by 2. Here 0. So we got the values of x1, that is 3, 1, 1 by 2, again 1 by 2, minus 1 by 2 and last one is 0. Now we need to find out the values of S2 is equal to old values of S2 minus intersectional element into values of entering variable. Values. Old values of S2 are 8, 1, 1, 2, 0, 1. 0, 1. I am not taking 0 because it is A1. Minus intersectional element of S2 is 1. So 1 into. Right? Now values of the entering variable. Entering variable values are 3, then 1, 1 by 2, here also 1 by 2, minus 1 by 2 and 0. These are the values of the entering variable. Now 1 into 3 is 3, 8 minus 3 is 5, 1 minus 1, 0, 1 minus half is half, 2 minus half, that is 2 minus 1 by 2, LCM is 2, 2 2s are 4 minus 1, 3 by 2. 0 minus into minus will become plus. So 0 plus half is half. 1 minus 0 is 1. That's all. So we got the values of S2. What are the values? 5, 0, 1 by 2. Then here 3 by 2. Here it is 1 by 2. And last one is 1. So we got the values of S2. We got the values of x1 as well as s2. Now we need to calculate zj value. Multiply cj. 30 into 3 is 90. 0 into 5 is 0. So here comes 90. 30 into 1 is 30 because 0 into 0 is 0. 30 into half is 15. 0 into half is 0. 30 into half is 15. Then 0. Then 30 into minus half. So minus 15. We'll get minus 15. 30 into 0, 0. 0 into 1 is 0. That's it. Right? Now Cj minus Zj. 30 minus 30, 0. 30 minus 15 is 15. 10 minus 15 is minus 5. And 0 minus minus 15 will become plus 15. 0. Optimality test says all the values should be zeros and positive. We should not have negative, but we got negative. So again, it is not optimum solution. We have to make one more table, right? So which is negative? Here only one item is negative, minus 5. For which variable? X3. So in the next iteration, X3 will come. Next table, the entering variable will be X3. Now which is the departing variable? Depends on minimum ratio. Minimum ratio is 3 divided by half. 3 divided by half. And 5 divided by 3 by 2. So 3 divided by half. So 3 into 2 by 1, that is equal to 6. 5 divided by 1 into divided by 3 by 2. So if you multiply 2 by 3. 2 by 3. 5 2s are 10 by 3. 3.33. 10 divided by 3 means 3.33. Now 6 or 3.33, whichever is lower, that will depart. So 3.33 is lower. So which one will depart? S2. So in the next table, X3 will enter and S2 will depart. So we have completed the simplex table 2. In this simplex table 2, we come to know that the entering variable will be X3 and the departing variable is S2. So another table will make simplex table 3 where X3 enters and S2 departs. So see here, simplex table 3, X3 enters and S2 departs. So same table. And remember, when S2 is departing, but still we have to make the column of S2. Don't remove. Only in case of artificial variables, if it is departed, no column should be made. But for surplus and slack variable, even if it is departed, we should open the column of S1 and S2. Right? Now, first of all, X1, for X1 value, X1 will remain as it is. In place of S2, we are writing X3. First of all, we need the values of the entering variable. Here the entering variable is X3. So how to find out the values of entering variable? Values of departing variable divided by intersectional element. Which is the departing variable? S2 is the departing. So what are the values of S2? 5, 0, 1 by 2. So here 5, 0, 1 by 2. 3 by 2, 1 by 2, 1. 3 by 2, 1 by 2, 1. So we have taken the values of the departing variable divided by intersectional element. The intersectional element is 3 by 2. So divided by 3 by 2. All divide by 3 by 2. So 5 into divided by 3 by 2. So if we multiply, it will become 2 by 3. So 10 by 3. 5 2s are 10. 10 divided by 3. 0 divided by 3 by 2 is 0. 1 by 2 divided by 3 by 2. So I can write 1 by 2 into 2 by 3. We are converting the division into multiplication. So it will become reciprocal. So inverse. So 2 divided by 2 will get cancelled. So 1 by 3. 3 by 2 divided by 3 by 2 is 1. 1 by 2 divided by 3 by 2. So I can write 1 by 2 into 2 by 3. 2 will get cancelled, remaining 1 by 3. 1 divided by 3 by 2. So 1 by 1 into 2 by 3. 3 by 2 will become 2 by 3. So 2 by 3. That's all. So we got the values of the entering variable X3. X3 values are 10 by 3. Second one 0. Then 1 by 3. Then 1. Then 1 by 3. Then last one 2 by 3. So we got the values of the entering variable. Now we need the new values of x1. So new values of x1, the formula will be old values of x1 minus intersectional element into values of the entering variable. So what are the old values of x1? 3, 1, 1 by 2. So here 3, 1, 1 by 2. Then 1 by 2 minus 1 by 2, 0. 1 by 2 minus 1 by 2, 0. These are the old values of x1 minus intersectional element of x1 is 1 by 2. So in bracket 1 by 2 I have taken, multiply by value of the entering variable. Entering variable are 10 by 3, then 0, then 1 by 3, then 1, then we have 1 by 3, and lastly 2 by 3. Now simplify. 2 1s are 2, 2 5s are 10. So it will become 5 by 3. So 3 minus 5 by 3. If you take LCM 3, so 3 3s are 9. 9 minus 5 is 4 by 3. Similarly, 1 minus 0 is 1. 1 by 2 minus 1 1s are 1, 2 3s are 6. 1 by 2 minus 1 by 6. LCM is 6. 2 how many times cut 6? 3 times. 3 1s are 3. 6 how many times cut 6? 1 time. 1 1s are 1. So 3 minus 1, 2 by 6, or we can take 1 by 3. So half minus half will be 0. 1 by minus 1 by 2 minus 1 by 2 into 1 by 3. Minus 1 by 2 minus 1 by 6. So LCM is 6. 2 how many times cut 6? 3 times. 3 1s are 3, minus 3. Minus 6 one time. So minus 3 minus 1 is minus 4 by 6 is equal to minus 2 by 3. Lastly 0 minus 1 by 2 into 2 by 3. 2 will get cancelled. So remaining 1 by 3. So minus 1 by 3. So we got all the values of x1. So what are the values of x1? First one 4 by 3. Then after that 1. Next one is 1 by 3. Next value is 0. Then minus 2 by 3. And last one is minus 1 by 3. That's all. So we have calculated all the values. Now we need zj value, right? So multiply. Here 30 into 4. 30 into 4 is 120. 120 by 4 plus 10 into 10, 100. 100 by 3. This is also 3. 30 into 4 is 120. 120 by 3 plus 100 by 3. LCM if we take 3, then 120 plus 100. That is 220 by 3. Right? The 30 into 1 is 30. 10 into 0 is 0. So here remains 30. Then 30 into 1 by 3. So it will become 30 by 3. Plus 10 into 1 by 3 is 10 by 3. That comes to 30 plus 10 is 40 by 3. So here comes 40 by 3. Next one is 30 into 0 is 0. 10 into 1 is 10. Then 30 into minus 2 by 3 is minus 60 by 3. Plus 10 into 1 by 3. So 10 by 3. That comes to minus 60 plus 10. So it will become minus 50 by 3. Minus 50 by 3. Last one, 30 into minus 1 by 3. 30 minus 30 by 3. Plus 10 into 2, 20 by 3. So LCM if we take 3, so minus 30 plus 20. It is minus 10 by 3. Yes, minus 10 by 3. That's all. So we got all the values of zj. Now we need cj minus zj. That is the index row elements. 30 minus 30, 0. Here 30 minus 40 by 3. 40 by 3. If you take LCM 3, 3 into 30 is 90. Minus 3 cancel, 1 time 1 into 40 is 40. So 90 minus 40 is 50 by 3. So here I am taking 50 by 3. Here 10 minus 10, 0. 0 minus 50 by 3. This means like this, 0 minus 50 by 3. So minus into minus will become plus 50 by 3. Similarly here, 0 minus minus 10 by 3. Minus into minus will become plus 10 by 3. That's all. Optimality test says all the index row elements should be zeros and positives. And we got all the zeros and positive. We don't have any negative element. So this is the final simplex step. We cannot make further improvement. Whatever cost we got 200 by 3, this is the minimum cost. That's all. So after completing this table, you should write the conclusion. Since all the index row elements are zeros and positive, no negative element, so optimum solution is reached. The optimum solution is x1 is equal to 4 by 3. This we should write. x1 is equal to 4 by 3. x2 is equal to, do we have x2 in the solution? No x2. So x2 is equal to 0 and x3 is equal to 10 by 3. And the minimum z is 220 by 3. This is the solution. That's all. So this is the first problem on mixed constraint, less than equal to and greater than equal to. So two more problems will solve on this mixed constraints. Remember, only watching the video will not be sufficient for your preparations. It requires your time, your hard work, your patience, your practice. Then only you can be able to get the command on this simplex table. Already I told you in the earlier videos, in the whole operational research, the most time consuming complex method, complicated method is simplex. Remaining all other chapters like networking or transportation or assignment or simulation, queuing theory, game theory, all the topics are easier compared to simplex. Even if you commit a mistake like minus 2 plus or plus say minus, then the whole problem will go. That's why it needs a lot of practice. So inshallah we'll continue the next problem in the next video.